Hey everybody, thanks for joining me again today. We're going to talk some more about probability. So this is where our notes continue. These are the same notes from yesterday if you printed them off. Part 2, the I can statement is the same. I can compute the probability of simple events. Alright, so let's do our warm-up here. It says example 4. Assign a 0, a 0.5, or a 1 to estimate the probability of each event. And if you'll remember, 0 is what the probability is if it's not going to happen. No way, no how, it's just impossible. Then the probability would be a 0. On the other hand, if you're completely sure it's going to happen, if it's a certain thing, then you should give it a 1. So example A here, it says, you are in Utah right now. Now, strangely enough, we're in virtual school. It's possible that some of you guys are not in Utah right now, but pretend we're all sitting in a classroom somewhere in the Jordan District. In that case, the probability of us being in Utah right now would be a 1. It would be a certainty. So I'm going to go ahead and put a 1 there. What about part B? Pizza will fall from the sky at lunchtime. Do I have any Cloudy with a Chance of Meatballs fans out there? If we were in the town of Chew and Swallow from that book, maybe it would happen, but we live on planet Earth in Utah somewhere. And pizza, unfortunately, does not fall from the sky, so that is going to get a probability of 0. Although I could definitely go for some pizza right now. Okay, part C. You roll an odd number on a die. Okay, so a standard die has 1 through 6. Has 1, 2, 3, 4, 5, 6. So half of those are odd numbers and half of those are even numbers. So the probability of rolling an odd number is 1/2. Now, if you wanted to count it up out of 6, you could say, let's see, there are 6 total possible outcomes. So you could put a 6 on the bottom. And the odd numbers would be 1, 3, and 5. So there are 3 outcomes that give you an odd number. So you could say 3/6 and then simplify that to 1/2. Whichever way you want to think about it, it's pretty much the same thing. So whatever way works for you. Let's go on to example 5. It says a drawing is being held at a school party. There are 20 prizes in all. 7 Sour Patch Kids, 8 Whoppers, and some Pringles. They don't tell us how many Pringles, do they? Use what you know about probability to do the following. First, make a probability model for this situation. Okay, and remember in this probability model, we're going to list all of the possible outcomes and then the probability of each. So what are our possible outcomes here? First, we could have Sour Patch Kids. So if we want a drawing, we might be winning Sour Patch Kids. What might we be winning? We might be winning Whoppers. And what is that third possible prize? It is Pringles. Still talking about food. I'm getting hungrier and hungrier. Okay, so now we need the probability of each. Now they already tell us there's 20 prizes in all, so we know that whatever the probability is, it's out of 20. So we can put 20 on the bottom of these ratios. And so I'll just go ahead and write them like that. I'm leaving some room on the right in case we need to simplify any of those fractions. Okay, so what was that probability of Sour Patch Kids? 7 out of 20. So we'll just do it like that. What about Whoppers? There's 8 Whoppers that you might win, so 8 out of the 20 prizes. And then Pringles, they don't tell us how many of those, but we can figure it out, right? So we know if there's 20 prizes in all, 7 plus 8 plus whatever number of Pringles needs to add up to 20. So 7 plus 8 is 15, and 15 plus 5 equals Pringles. So you can put your 5 here. Now I just want to point out another way you could have gotten to the same number is to look at your probability model. You know that the probability of all 3 outcomes needs to equal 1, correct? So it would need to equal 20 out of 20. So you could have thought to yourself, let's see, 7 plus 8 equals 15, and we need to get to 20 on top, so we need another 5. 15 plus 5 equals 20. So just 2 different ways to think about that, and remembering that all of these in the probability model have to add up to 1. Okay, so next up we just need to simplify. Let's see, that's already simplified. 8 out of 20, we can simplify that. Let's divide the numerator and denominator by 4. So 8 divided by 4 is 2. 20 divided by 4 is 5. Okay. What about 5/20? Let's divide them both by 5. So 5 divided by 5 is 1. 20 divided by 5 is 4. Okay, so we're all simplified. We are done with our probability model. Now let's answer some questions. What is the probability of winning a can of Pringles? Okay, let's go down here, find the Pringles. It looks like the probability is 1 in 4, which we just write like this. Okay. What's the probability of winning Pringles or Whoppers? Okay, so now when you have it stated like this, where there are these two possible outcomes that you're looking for, then you just need to add them together. So Pringles, we need to add the probability of Pringles to the probability of Whoppers. So the probability of Pringles, we're going to stick with the out of 20. We're going to stick with the unsimplified ratio here because it'll be easier to add because that way they both already have a common denominator. So we're going to add 5 over 20 to 8 over 20. And let's see, 5 plus 8 is 13. We keep that denominator the same, so it's just over 20. So the probability of winning Pringles or Whoppers, you combine these two and you get 13 out of 20. Okay, let's do another example. Example 6. This one's a little bit different. What is the probability of the spinner landing on a number less than 3? Okay, look at the spinner. Do you see anything funny about that spinner? That number 3 is extra big, isn't it? So the simplest way to think about the probability in this situation is just to divide this little wedge here in half. And when you do that, you have 8 equal wedges. 1, 2, 3, 4, 5, 6, 7, 8. And it just so happens that 3 takes up 2 of the wedges. Okay, so that's how we're going to handle this one. So what is the probability of spinning a number less than 3? Well, you could spin a 0, a 1, or a 2. So there's 3 different ways to spin a number less than 3. I'll put that 3 on top. And what was the total number of possible outcomes? 1, 2, 3, 4, 5, 6, 7, 8. Go ahead and count that twice, okay? So that's going to be out of 8. Okay, what about part B? What about a number 3 or less? Okay, so this time you have to still include 0, 1, and 2, but you also have to include 3 because that's included in 3 or less. So this space, I'll just circle it there, and this space, both are counted now. So let's count up the total number of ways to spin a 3 or less. 1, 2, 3, 4, 5. Okay, and it's still out of a total of 8 different outcomes. And okay, so we're done with that one. Let's go to example 7. If the following table represents the number of brass instruments in the horn section of the Utah Symphony, what is the probability that a horn player selected at random will play the following instruments? I'm going to scribble that out. It shouldn't say horn player. It should say brass player. You band people probably know that already. So if they select a brass player at random, what's the probability that they will play the tuba or the French horn or trumpet or a brass instrument that starts with the letter T? Well, let's take a look at this over here. We've got our probability model that we're reading. So we need to know the likelihood, the probability that the player will play the tuba. Well, how many tubas are there? It looks like there's only one, right? So our top number is going to be a 1. Now, what number is going to go on bottom? We don't know yet because we don't know the total number of possible outcomes. So let's add them up. You're going to have 3 plus 1 equals 4, plus 5 equals 9, plus 3 equals 12. Let me add them up again just to make sure I didn't mess that up. 6 plus 6, 12. Okay, yes. So you're going to have 1 out of 12 because all of these total to be 12. And by the way, I believe I called this a probability model a second ago. This is not a probability model. This is just a chart. So I was just getting ahead of myself. So we're reading this chart and figuring out probabilities over here. Okay, so we have it done for tuba. What about if it was French horn or trumpet? So we need to add those two together and then put them over 12. So French horn, there's 3 of those. And trumpet, well, there's 5 of those. So 3 plus 5 is 8. I'll put that number on top. And still the total number of possible outcomes are 12. So 8 over 12, that can be simplified into 2/3. Okay. Now, how about a brass instrument that starts with the letter T? Well, French horn doesn't start with the letter T, but tuba, trumpet, and trombones all start with the letter T, so let's add those up. 1 plus 5 is 6, 6 plus 3 is 9, and we still put it over 12 because there's 12 possible instruments here. Okay, so 9 over 12, those numbers can both be divided by 3, and you're left with 3 over 4 once it's fully simplified. And that is your final answer. So this is your assignment here. This is kind of like that first example we did on the notes. It says you attend Elk Ridge Middle right now. Well, if you're an Elk Ridge student, I guess that's going to be a 1. And if you are not an Elk Ridge student, I guess you're going to put 0 for that. So you guys will have different answers for that one. Here you have something where you're building a probability model and a bag of blue, green, and red chips, spinners. We got all kinds of stuff here for you. You guys work on this, and if you have any questions, let me know, okay? I want you to work on this for a good 30 minutes. If you're finding that it's taking you forever, it is okay if you skip the last few problems, all right? And I do want you to skip these also. And, all right, thanks so much for watching. If you have any questions, let me know. I love hearing from you, and I'll see you next time. Bye.